Welcome to the afternoon session. Hope you all had a nice lunch. I've been told I've got 25 minutes. This presentation I normally do in about an hour, so I've got to squeeze it down by quite a bit. So I'm going to move at pace, I'm afraid, so I apologise if I speak very quickly. I'm going to try and cut a few bits out because I've been told also we need some questions and answer time at the end, but I will be moving quickly. But there's a lot of stuff that I want to talk about. And we're talking about here about really this information modelling for construction. That's the subject matter. And what I want to do is not talk about what everyone else has been talking about really currently, which is what we're doing now in terms of BIM. You'll hear lots of other speakers this morning and this afternoon talking about what the UK government call level 2 BIM, trying to achieve level 2 BIM. I want to talk about where we're going in the future and how we're going to support level 3 BIM and where we are currently now. That's what I like to talk about. So it's really this sort of the enhancing technology even further. So it's the next step, if you like. Where's this thing? I hope it's right. Technology crash first time. Here we go. Yes, that's me. Right. So in doing what I would like to do actually is talk about the first thing we did was actually speak to the industry. We wanted to find out what people were looking for. And in doing that, we needed to understand the challenges that they have. And that helped define what our system is going to be. So I'll quickly go through that very quickly. And then after that, after explaining the challenges and what contractors told us what the challenges were, I'll explain what we're doing to deal with those challenges and the systems that we're developing now to support and make things better. So the first thing is the challenges. The first thing, that's probably about 2 years in total, we spent talking to various construction companies of various sizes, large and small. The larger ones in particular were often building their own systems because what they couldn't find anything off the shelf. There was bits and pieces, but they were gluing things together themselves. And that gluing together and the way in which they did things was effectively the differentiator. You know, you would have the Bechtel way, the Bouygues way. You had these different ways of working, which were great because it enabled them to be a contractor that was doing things differently and working differently. So that was the differentiator. There was lots of legacy stuff in there, an awful lot of Excel also in there. But what lots of them were looking for was actually, we're a construction company or an EPC. We don't really want to do this. We want to buy software off the shelf that will help us to do that. So they're looking to, and it was quite an overhead and a burden to do that. So the other challenge, I mean, these are all, for those of you, these are all very common, so I won't dwell on them. But the main ones really are this maintaining of profit margins. We all know that construction margins are really quite tight right now, so that's important. Cost and time certainty is even more important. Recently in the UK and London, we've been working on the Olympics. Cost and time certainty was a must, for example. Crossrail is another one. Also, a clear understanding of risk, identifying the efficiency of the supply chain, because contractors are only as good as their supply chain. So that was another thing they wanted to do. How can we make our supply chain well? Having good change control and transparent. Change control was important. If you don't manage change, you don't manage a project. And the last thing was doing all of this with environmental standards and other standards, safety standards and quality standards, all at the same time. The other thing really was, well, the main thing that we came down to in terms of what Bentley can do is that it's all about, for us, it's all about information. And it was getting the right information to the right person at the right time. That's the crux of it all. But there was another thing, which is this word kept coming up, predictability and certainty, and this visibility of predictability and certainty. And then we asked, well, how do you get, what impacts on predictability? Now, a lot of it is nothing to do with technology. The first thing, big ticket item was how they treated risk. Some organisations treated risk as a commodity. Clients treated risk as a commodity. Oil and gas industry, the clients always treated risk as a commodity. BP is an example of that. Now they don't. But so treating risk in the way in which you manage and treat risk was one clear way of dealing with predictability. Also, the contractual relationship also had an impact on that predictability and visibility into that predictability. And this last thing was this openness and the transparency of the supply chain, being able to get good reporting and KPIs back up through the supply chain. That was another one. And what we mean by that was that generally, if you take many clients, a client will have a relationship with a program contractor. I'm thinking about big projects now, so it depends on the size of the project. But say it's a big project. They will then have sub-projects to main contractors, and those main contractors will have subcontractors. But effectively, what's happening, the further down that supply chain you go, the less visibility you have. And there's lots of organisations who are trying to improve that by having various automated and semi-automated ways of doing that, through spreadsheets, sometimes through web-based HTML dashboarding. And basically they were coming up through the supply chain with information that was very often seen as be subjective, and but it was pretty good, but it wasn't necessarily accurate. So what we found was really this sort of lack of visibility down the supply chain increased the risk as you go back up to the top. And that risk generally meant money and also meant time. So people were, that's where the... So the other thing really with these projects, particularly CAPEX projects in particular, was this lack of connectivity between not just the contractors but also within the contractors themselves and their supply chains. There were silos everywhere, and all organisations have silos. I keep pushing that. And it was really the same in many construction companies, and it was those silos that many construction companies were trying to join up themselves. It was that glue they were trying to provide. And this isn't all of them, by the way, this is just an indication. There's just some of them as you move down the supply chain. So we needed some way, is there some platform that we could create that could support and manage all of those? Now the problem is what we don't want to do is build something that's the big brother to everything. It's impossible to do that. If we could do that, we would do that. But, and the other thing that was really important was that it must be open and be a trusted environment. That was an important thing. It also must respect the fact that organisations have made considerable investment in systems already. You know, if we, for example, financial systems, SAP, sometimes Documentum, procurement systems, scheduling systems like Primavera, they're not going to change those. So we need to be able to work with them and link with those rather than replace them. It's important. Also, linking rather than copying out was another thing. Being able to link to things, and if you are copying out, it's in a controlled and managed way. And also respect data ownership and also copyright, particularly with architecture. Architects have copyright, for example, so how do we manage that? And also enable good decision making to that entire CAPEX process. And finally, this thing that kept cropping up over and over again, handle change. So that was what we needed to build. Not an easy task. The first thing we thought about was, where does it fit? I mean, this is a very simplified diagram of the sort of the OPEX, CAPEX world, but effectively an owner has a portfolio of assets, projects are coming and going, and there is this relationship between where you're creating projects, you're building new assets, bringing them on stream, bringing them on time. So it felt right for us to sort of push this inside the ProjectWise brand. So for those of you that are familiar with ProjectWise, it will sit on that side of the table rather than the AssetWise side of the table. So what we want to do is build an off-the-shelf solution, primarily for EPCs, general contractors, owners. We wanted to be able to build it for organisations that are close to being ready to accept it. Now, the industrial world is probably the closest to be able to accept it, quickly followed by the building world, because you're working in objects already. But the industrial world are quite some way ahead. And infrastructure as well. So on the technology side and the adoption side, there's a readiness and adoption for the industrial world already. In terms of the scope, we wanted to cover, I said we must cover everything. It must cover cradle to grave of the construction process as much as possible, from the tendering and bidding process right the way through to commissioning and handing over and turning over at the back end, all of those bits. So, and the other thing is, in doing that process, what we identified was that there was an awful lot of, as you move that through that process, there's information passing backwards and forwards all the time in forms of work packages. You can call them whatever you like, but it was bundles of information going backwards and forwards, and it was these work packages. I'll come on to these again later on, but it's this work package that we identified as being as a key currency of exchange, if you like. So the other thing was, and again, normally in my hour-long presentation I go through all of these one by one, but I won't do that. So basically we have the phases, if you like, the sort of work winning, early planning, the design, engineering, procurement phase, and all the phases we know about. And whether you are REBA stages or whether you are the civil engineering phase, there's various different phases of construction, or FEL if you're in the industrial world. They generally fall into these different types of phases, and there are a series of workflows and activities that take place in all of those. Now, there's certain places we definitely did not want to go. We don't want to go into the financial world. We don't want to be another SAP. We don't want to. We don't want to be at a really large, for example, in estimation. There's certain things to do with money where we don't want to be. But there's a lot of other places where we do. But we do need to link to money. We don't want to replace Primavera. But we want to link to Primavera, for example. The other thing we identified as we went through this process, there were some really good point solutions. But what they weren't was integrated. So they worked very well, but they worked in isolation. So our vision must be that we wanted to uncover the entire scope. Now, we can't do that, so we'd need to do that by either building it, acquiring it, or partnering, or at least working with organisations where you can say that the solution works because we're partnering with all these people. So that was really important. We need an acquisition strategy and a partnership strategy, which we've got. The other thing is that there really needs a high degree of interoperability. So it needs to be a relational database, effectively, which is what it is. We must build it for the cloud, but it needs to work without. Lots of organisations don't like things in the cloud. Governments don't like things in the cloud. In certain places of the world don't want things in the cloud. So it's got to be able to be built for the cloud, but not necessarily work without the cloud. It's got to be modular and scalable. Modular meaning that people will generally adopt technology over a period of time. It's more of an evolution rather than revolution, so it must be modular, and it must be scalable. This thing mustn't be the mother of all systems and therefore unaffordable and only used on big projects. It's got to be scalable. And the other thing, we've got to keep our proprietary to a minimum. So many organisations are saying this file format, this file format, this file format, and we're saying it's got to be open. We want to follow ISOs wherever possible, we want to follow IFCs, COBIs, etc., 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 but it's got to be open. And we must provide this visibility and predictability into the path of construction. The other challenge that we had was that it's not just building for us, it's got to cover all sectors. It must be a platform that covers both building, infrastructure, oil and gas, anything. So, and then as I said before, we started with industrial and we're going to then move on to infrastructure and building at the same time. So this platform, the first thing is bringing this information together. What is this platform? What does it need to do? Well, in its simplest terms, it needs to bring in models, it needs to bring in schedules, it needs to bring in cost, it needs to bring in resources, materials, equipment, anything from an ERP system, and many other things. But it needs to be able to handle all that information, as I say, in some instances, leaving it where it is and just linking to it. And once you've done that, you can then carry on doing extensive construction modelling, because modelling doesn't finish when you finish design. Lots of modelling carries on through design. You'll hear later on some of the construction guys telling you how much modelling they actually do, especially for scheduling, for example, and other estimating, etc. Being able to create work packages from that, take that model, break it up into pieces and distribute it through supply chain, work package management, being able to do visualizations and statusing, and being able to do things in the field on that database, and then that's QA and QC, and then good dashboards and good reporting. And again, that big thing change. So the platform, it needs to be normalized, it needs to be open, it needs to be SQL. So that's what we've decided upon. We had a choice of Oracle or SQL, we've just chosen SQL. And it must be component-based. I'll come on to that in a second, a bit later on. The difference between component-based and file-based. I'll explain that later. But generally, it must be component-based. On top of that database structure, we need to have business process. That business process includes things like document control, document management, work package management, workflows, change control, and impact analysis. On top of that, we need good data quality management, rubbish in, rubbish out, that old scenario. It's got to have good data quality management because this is a key system. And there are a series of other services that we can put on top, total operational services. And there's obviously, like all systems, it must be role-based and it have to have security associated with it. It's important also for us because we're not going to build everything. We wrap it up with the software developer kit. It's got to be able to enable others to build on top of it. We can't make it totally our own. And of course, this is where, when stuff comes in from Primavera, from material management systems, from equipment, from Trimble, from anywhere, wherever the information comes in, it goes in via data quality management and comes back out the other end as well. So we're normalizing content, we're linking content, and we throw things out the back end in the same way. Again, to standards. When we talk about normalizing content, we'll be talking about BIM here. Those BIM models sit within products like Revit or our own products. They all sit inside these multiple systems. We need to be able to bring those in and normalize them. And once we've got them in there, we can start beginning to build what we're calling a virtual construction model. Once we have that virtual construction model, we then need to do things in it, with it. For example, we might need to do things like some construction execution work, some planning work, some constructability reviews, but all again on this componentized structure. Now the componentized database still records the WBS, the SBS, the OBS. It still has all of those things in it, still built inside the system. It hasn't gone away. And then there's going to be those users that need to consume the data that's been created. So there'll be people in the field carrying out inspections and surveys. There'll be people that are looking at portals and dashboards, and there'll be people that are looking at visualizations and other sort of status visualizations too. So there'll be someone consuming the data and data collection. So going back to this sort of predictability statement I made, and really The level of, again, hopefully this diagram isn't too complex, it's relatively, I'll try to make it as simple as possible, but basically the things that affect predictability is the level of information you're working with. So if you're working with paper, you've got pretty poor levels of predictability in information management. As soon as you start working with CAD and BIM models and file-based, you're getting better, but ultimately what you really need to be is this relational, componentized database. And once you get to that level, then you get increases in predictability and visibility and reduction in risk because you have much better quality information. And that diagram sort of reflects the sort of the UK government strategy diagram produced by Mark Buer and Mervyn Richards. And really where what we're trying to build is this core IM system for level 3. That's what we're talking about. We're not talking about building BIM products. We're talking about building a platform to support BIM level 3. So if we look at that platform now in terms of the life cycle, we want that platform to be able to support all of those processes, and this is another view of that diagram, and I'll explain why in a second I'm using this diagram. And again, it must link to these other systems. Over and across that entire process, we need to have work package management and change management and being able to have analysis and dashboards. This diagram helped us to really think about how we present the product, because one of the other things we need to be, it must be simple to use. Lots of products are overly complicated. Multiple screens required to do this stuff. We needed to keep it simple, big button stuff. So we came up with this process of, this was some early drafts of what it's going to look like, where as it reflects the life cycle of the project effectively. So you have design management, early planning, work packaging, etc. And this is effectively a skin over the top of the database. And this skin can be, it could represent different sectors, for example. Here's just a few other examples here too. So the first thing is bringing this content into the system. And again, we can bring it in from multiple systems. We bring it in via an I model. For those of you who don't know what an I model is, we can explain it later on, but we don't have time now. But we're bringing content in. We're bringing content in from anywhere through this database and normalizing it. If we now look at, say, this work packaging, this is the simple process of moving content throughout the supply chain. And as you're doing this and moving information around the supply chain at a component level, in the field, you can then progress in the field. You can check in the field. And effectively what's going back up the stream, back up to the top of the tier, is now an accurate report of where you actually are in the process. You get better predictability and traceability. And it's at this point we want to manage change. We needed some mechanism to hang change off, and it was this work packaging process that we decided to hang change from. So I'll give you a quick look at the construction server, and it's going to be a really quick look, and it's just screenshots, but it gives you an idea of where we are. There are three, at the moment we have a planning tool, we have a general project dashboard, and we have field applications at the moment. And again, we'll be building up more and more. But the main thing was building up that core server in the first place. So if we look at the dashboard as it currently stands, you log into the system as normal. And it's called WPS right now because we're dealing with work package services right now, but it's going to change. For example, here you can see that it's got engineering, work packages, construction, and progressing and quality. Those are the things we're focusing on right now. And that's the main dashboard. That's repeated again at the top, and there's a pull down which enables you to create work packages, for example. So here, I don't know if you can see that. Yeah, it's not too bad. Here you can see that there's a series of work packages that have all been created, and there's different types of work packages that are in there. There's engineering work packages, which effectively that's an engineer, that's in the industrial world. There's a construction work package, an installation work package, and a test work pack. So these are all the different packages. Again, once you click on a package, you can see all these packages and you can see how well they're progressing in terms of time. And there's no reason why that couldn't be financials as well, but in this instance we're just looking at time. And you can create another one, so it's a one button click for creating them. So here we're now going to look at that work package. Inside that work package you can see the schedule associated with it, any contracts, any tasks associated with it, and those tasks are at a component level, and I'll show you that in a second, any drawings and documentations associated with that. And also it shows you the overall progress. It looks at status and looks at predicting how the project is progressing and other general information about the package. If you look at the tasks quickly, all the tasks down here, these ones down here, have all come from the component themselves has come from BIM, and the tasks have been applied through our system. So there's the tasks and activities associated with an object are applied in our system. And again, those are all customizable. You can change the activities and tasks, etc., associated with them. Also, there are the relationships between this and material management systems, between this and planning systems. But effectively, this is this is just one dashboard. And here you can say this is the progressing dashboard. And here you can see you've got the areas where you can progress by quantity, areas where you can progress by time, and areas where you can progress just by overall progressing. There's also a history associated with every object that's in the system. Again, simple buttons here, it's one click, big buttons. In the planner's view, they basically take content from the system, they download it into their desktop. Because some of these files can be very large, it is a syncing process, they can download it to the system, and here they can carry out things like creating work packages, doing status visualization, looking at scheduling, last planner techniques, etc., all that sort of stuff. They can do additional tasks as well. There's a graphical view pane, and you can see here that the two systems are synchronized when they come in. And again, as you drill down into each individual work task, you can see the activities which reflect what's in the server. So a planner would download them, he'd work on the system, and then work offline, and then load them back in again. So that's the general process for a planner, and that would be repeated for any other type of person working on the project. Again, this is a single button creation here. I'm going to whiz through this really quickly because we're running out of time. But it gives you an idea that the system is there. It's working on the industrial world. And here, for example, a planner is actually selecting components to put inside a work package, and the system knows which ones have already been selected. For example, it tells you that you can't select that one because it's already been selected for a package, for example. But as you're building up those packages, it's actually telling you how long it's going to take because of all the information around it. And let's just go through really quick here because I've only got 2 minutes left, so I'm going to quickly go through here. The other thing is you've got multiple team members. Because we're working at component level, it does manage a conflict resolution inside the system. And these are just examples of various status visualizations for materials and other, etc. In the field, we've already been writing a number of applications already. Those applications at the moment don't necessarily work inside they have been built ready to work inside this server environment. So, for example, the mobile navigator is a SQLite database in a mobile environment. So that's been done. Others will gradually be brought into the system, so the inspections and other ones. But for example here, if you're doing field progressing or visual status reporting, you can take content from anywhere, put it into an ARM model that goes into our system. The system normalizes all of that content. Any reports that are generated could be associated with all of those activities, and effectively you can take in the field a status visualization of the whole thing. So does it work for infrastructure? And I've got exactly 3 minutes left, and I'm doing really well because I've got 3 minutes left on my presentation. Right, yes it does. We've been testing it we've tested it with Revit, we've tested it with our own products. So we can bring these things in, and again, this is now looking at a Revit file here. We're able to break the things up, normalize all the content. We're able to apply activities to those so that as you're adding elements to it, it adds up. You can do look-ahead planning, you can do a constraint analysis on those activities, we know that works. In the civil world, we've tested it on other things that works in the civil world. Generate work packages here, again, this is looking at curbing, etc. So generally, the basic underlying principle works. We've been building it for infrastructure. There's a lot more data for the industrial world, and we want to do that same thing for the building and infrastructure world. So with that, I've finished on exactly 24:54.